Okay, so today's lesson is going to be on linear equations. We've already looked at a little bit of linear equations so far, but we're going to look at a couple, or in particular, one extra type of linear equation today that we haven't looked at before. So let's get going. It's going to be a pretty short lesson today. When I'm filming this right now, it's November 29th, so it's right before the end of 2020 shutdown that we had for a few weeks in schools. If you're watching this at some other point, you can just ignore this preamble, but I basically wanted to start this very first online lesson a little bit lighter today, just to kind of give us a chance to get used to the new system. But anyway, today's plan will be we'll have a quick recap of solving ax equals b type linear equations and x over a equals b type linear equations. These are what I refer to in class as being one-step problems. I'll even write that, one-step problems. In other words, these are problems that generally speaking can be done in one step. But we are going to introduce a more challenging type of linear equation today. This is a over x equals b, which I know looks very similar to the one that we had done before. But believe me, there is an additional step. This one is actually a two-step problem, even though it looks very similar to a one-step problem. Anyway, let's get going here. I would highly advise that you write these examples down as we go through. So in other words, if you need to pause just to jot a question down, by all means do that. But let's get going. So we're going to solve the following. These are some examples that we had done in some notes in class before, but it doesn't hurt going over them a second time just to make sure we're clear on what to do. Very first question here, we have 9x equals 72. So this means 9 times something equals 72. The key to solving linear equations when we're trying to find what x is equal to is we should undo whatever is happening to the x. So in this case, we have 9 times x equals 72. To undo a 9 times, we have to do the opposite operation. Well, the opposite of multiplication, of course, is division. So to solve this, we should do the opposite of this. So we should divide by 9 on both sides. Now, the reason we have to do it to both sides is you can think of a linear equation as being like a balanced scale. So whatever you do to one side of a scale, you have to do to the other for it to stay balanced. Anyway, if we divide by 9 both sides, that actually knocks out the 9 here because 9 divided by 9 is just 1, so that's gone. On the other side of the equation, though, 72 divided by 9 is 8. So we're left with x equals 8. And that right there in one single step, just divide by 9 on both sides, in one single step, we were able to solve what x is equal to. Now for this one, 14x equals 84. Once again, since we're doing 14 times x equals 84, we should do the opposite operation, so divide by 14 on both sides. That'll knock out 14 over here, so we're left with x equals 84 divided by 14. I wouldn't blame you if you had to go to your calculator to get that one, but I'll tell you right now the answer is going to be 6. Last one up, it's kind of a changed order. It says 96 equals 4x. It doesn't matter that 4x is on the right-hand side this time around. Remember, we're always preoccupied with finding whatever's happening to x and undoing it, right? So in other words, what we see happening to x over here is it's being multiplied by 4. We should undo that by dividing by 4. So if we divide by 4 on both sides, that'll knock out 4 over here. Now, 96 divided by 4, even off the top of my head, I'm not fully certain about that, but if I type it into a calculator real quick, just to be sure, it is 24. So in other words, we can see 24 equals x, or if you prefer to write x equals 24. It doesn't really matter. Of course, the equal sign just shows that both sides are equivalent to each other. So either way you want to write it, usually I like putting x on the left-hand side a little bit better, it just flows better, but either way you write it, it's still going to be correct. All right, next slide. So these were the other type of linear equations that we looked at in class. These are x over a equals b type equations. This is basically the same idea as the one we did just before, right, where you were multiplying. This time we have x divided by 12 equals 6. Once again, we just want to do whatever's the opposite of what's happening to x. So what we see happening to x is it's being divided by 12. The opposite of dividing by 12 is timesing by 12. So let's just times by 12 on both sides of the equation here. That'll knock out the divide by 12 on the left-hand side, but what we'll be left with is x equals 6 times 12, and 6 times 12 I know is 72. Now, same with the second example. Notice x is being divided by -5, and that equals 30. To get rid of the negative or divide by -5, we just have to times by -5 on both sides. This is going to give us x equals 30 times -5. This is multiplication of a positive and a negative, so the answer will be a negative number. So that'll be 30 times -5 is -150. And the last one on this one, negative 13 equals x over 7. Just like the last slide, of course, we have the order kind of mixed up. Again, that doesn't matter. Just look at whatever's happening to x. We're dividing x by 7 here, so let's just times by 7 on both sides. That'll knock out this right here. And this will leave us with x equals negative 13 times 7, which I do not know off the top of my head, so give me a second. That'll be negative 91. Okay, here we go. So now for something new. This is where things really get interesting. A divided by x equals b, these type equations. These ones are a little weird. So these are trickier than the others, and I'll show you why. We have 8 divided by x equals 2. Now, some of you, right off the bat, you might say, okay, so 8 divided by something equals 2. You probably can figure out what that something is going to be. But if you can't, there is a better way of dealing with this. There isn't just a single step way of solving for this all in one go, because unfortunately, if you times by x on both sides, that is a good starting point, but you're still not left with the answer. Whenever you have an x in a denominator, so an unknown thing in a denominator, you actually should get it out of the denominator first for you to be able to solve what it's equal to. So I'm going to start by multiplying by x on both sides of this equation. Now I know that's not doing the opposite of what's happening to x, but because the x is locked in down here, it becomes too weird to start trying to figure out what that's going to be. So if I times by x on both sides, the purpose of that is it's going to get rid of this divide by x right here, and we're going to be left with 8 equals 2x. This looks a lot more like the questions that we started today's lesson with. So 8 equals 2x. To get x all by itself now, we just need to divide by 2 on both sides. So of course, 8 divided by 2 is going to equal 4. 2x divided by 2, that just knocks those 2's out, and you're left with x equals 4, which you might have been able to figure out in the first place. You might have said, oh, 8 divided by something equals 2. Clearly, that something's got to be 4. But this was an algebraic way of actually showing how you could determine that, rather than just pulling it right out of mental math. Okay? And again, showing your work is obviously quite important. All right, so here's some other examples. If you want right now, I'm not going to dictate it to you or anything like this, but if you want, you can pause the video right here, jot these down and give them a try on your own. But otherwise, right now, I'm going to go over them. So here we go. I'm going to start by going over 15 divided by x equals 3. Let's do that strategy I kind of told you. Let's times by x on both sides. That'll get rid of the divide by x here, and we're left with 15 equals 3x. And now that's a lot easier to solve, right? So we can just say, all right, we got to get rid of whatever's happening to x now. We just should divide by 3 on both sides. And that's going to give us x equals 5, because 15 divided by 3 is 5, and 3x divided by 3 is just x. And again, just out of habit, I always write the x on the left-hand side. So if you're kind of getting confused by the fact that those switched around, I apologize, but I think it is just better in math to put your variable first. X equals 5 sounds a lot better than saying 5 equals x. But I guess it's a matter of opinion. All right, anyway, this next one, let's times by x on both sides. And that crosses, of course, x out on this side here. So this leaves us with 54 equals 2x. And what do you know? We just got to divide by 2 now on both sides. Boom, boom. And we're left with x equals 54 divided by 2, which is 27. Last one here, negative 60 over x equals negative 15. This one's going to be a little bit more interesting. I'm not going to worry about this negative on the side here quite yet. I'm just going to start by timesing by x on both sides like I usually do. That'll knock out the x's over there. So we're going to be left with negative 60 equals negative 15x. Now, once again, we need to divide away whatever's happening to x. And I want you to notice we're multiplying x by negative 15 here. So we should divide both sides by negative 15. Oops, negative 15. There we go. That'll knock out the negative 15s on this side here. So we're going to be left with x equals negative 60 divided by negative 15. Remember, when you are doing either multiplication or division with two negative numbers, so negative 60 divided by negative 15, that's going to make the answer a positive number. So negative 60 divided by negative 15 is going to be positive 4. And that's our answer on that one. All right, moving on to the next one. A student scored 72% on a math test. All they know is that they got 18 questions correct. How many questions were on the test? So in other words, we want to find out the total number of questions that were on this test. Clearly, the student got some questions wrong because it got 72%, not 100%, but they do know they got 18 questions correct. Let's kind of break this one down first. 72%, let's think about what that means in the context of a test, like a test score. What that means is, of the questions, you got 72% of them right. So in other words, you could say right questions out of total questions equals 72%. So we do know they got 18 questions correct. So if we were to write that down, we'd say 18 questions correct out of an unknown total number of questions gave them 72%. So 18 out of something is 72%. Now there's one more issue here. A percentage in math listed as like 72%, that's actually useless in terms of calculations. Whenever you see this percentage sign, that's just for communication purposes. We don't actually like using 72%, for instance, in a calculation. So instead of writing 72%, we should change this to the other equivalent form of a percentage, and that's a decimal, right? So we just need to divide this by 100. That gives us 18 over x equals 0.72. 0.72 is the same thing as 72%, right? Even the word percent means per 100. Cent is like derived from French for 100, right? So the 72% means per 100, so that's why you had to divide it by 100. Anyway, I'm rambling. Now we have something more familiar with what we've been dealing with. 18 over x equals 0.72, just times by x on both sides. And we're going to be left with 18 equals 0.72x. And then there's one last step here. We just need to get x totally by itself. So let's divide by 0.72 on both sides of that equation. That'll cross out our 0.72s there. We're going to be left with x equals, and believe me, I'm reaching for a calculator right now, 18 divided by 0.72 gives us 25. So in other words, on that test that they had, there were 25 questions in total. 18 out of 25 gave them 72%. All right, here's another question. I think this is one of our last ones. 1 out of 9 people are left-handed. A school conducts a survey and finds that 120 people in the school are left-handed. How many students go to the school? This one is really, really interesting, actually. Wow, okay. So we know 1 out of 9 people are left-handed. So we could say 1 person is left-handed out of 9 people in total. This one's going to be a little bit different from the other ones we've set up, but not really to a huge extent. If we know there's 1 left-handed person out of 9 total, we can say that this is equal to the situation in this school where we know there's 120 left-handed people out of an unknown, so I'll call it X, number of people of total. This is what we call in math a ratio, or in other words, a proportion. We have something that we know. 1 person out of 9 that is left, so 1 out of 9 total, 1 is left out of 9 total people. And we can set this equal to a bigger situation, like 120 people in the school being left-handed out of an X number of people total. So if we ignore the whole fact that I've set this up, whoops, didn't mean to do that. If we ignore this whole fact that I've set this up with left in total, like that's really just kind of cluttering our equation, we can see we actually just have 1 over 9 equals 120 out of X. The question here is, though, how do we solve for x? We notice x is on a denominator here. And like I mentioned earlier in the lesson, we really don't like having x in a denominator. So I think the first thing we should do is times by x on both sides. That'll get x out of the denominator where it's not going to be so easy to solve, right? Now, 1 over 9 times x is actually going to be equal to x over 9. And in case you're not seeing it, you can imagine it if I'm just multiplying by a number like x, that's like multiplying by x over 1. So the tops have to multiply 1 times x, and the bottoms have to multiply as well, 9 times 1. This is going to be equal just to 120. So x over 9 is equal to 120. This becomes like one of those questions I did on the second slide today. That second slide was where it was x divided by something equals another number. We just have to get x all by itself now by undoing whatever's happening to x. So since x is being divided by 9, let's multiply by 9 on both sides. This is going to leave us, because the 9s are going to cancel out, this is going to leave us with x equals 120 times 9, which is 1,080 students in total. So hopefully that makes a little bit of sense. 120 students are left-handed out of 1,800 students, or 1,080 students rather in total, and that's just an equal proportion to 1 over 9. Rest assured, this is going to be a pretty advanced question for this. But the idea is just look at what you're given. 1 out of 9 people are left-handed, and set that equal to something that you know, right? So 1 out of 9 are left-handed. That means 120 out of some amount of students are as well. Anyway, so that's enough of me rambling today. I told you it was going to be a really, really quick lesson. The idea of today was just basically getting you used to this new this new layout. What I want you doing though is I want you to spend the rest of your normal block working on page 301, questions 1 and then 4 to 19. Now please make sure you're checking your answers. So check your answers using the solutions in the back of the book. And as always, if you need any help, make sure you're reaching out to me, especially during our regularly scheduled Zoom time. Anyway, best of luck, guys. And again, if you need me, please contact me.